Today we'll be dividing with radicals part 2. So divide with radicals part 2. We're just going to do some more work, get us more familiar and comfortable with the rationalizing and dividing of radical expressions. So page 66, divide with radicals part 2. We can skip 57, our objectives are the same. So go to page 66 and at the top we're dividing with radicals part 2. So we're on page 66 and at the top divide with radicals part 2. So page 66, divide with radicals part 2. So yesterday we had rules that we had. What is the first thing we need to know about dividing with radicals? The first thing that Miss Long starred yesterday, Braden. The denominator cannot be a radical. So anytime there's a denominator in the radical, we need to rationalize the denominator. So our first step from yesterday, what was it? Chance. Simplify the radicals. Simplify the original problem. So simplify original radicals. Our second step was no.
Multiply the numerator and the denominator by the radical and the denominator.
So to rationalize the denominator, we need to multiply the numerator and the denominator by the number in the radical, or the radical. So multiply numerator and denominator by the radical in the denominator, original denominator. And lastly, our third step was to, Zach, face forward. Zach, what was our third step yesterday? So simplify the problem. So we were just rewriting our steps from yesterday just to give us a little recollection, a little review. Before we move on, what type of problems would you guys like to see more of? So I can choose which problems we should use for these notes. A lot of ours wanted ones where we had to simplify first, or problems that had variables. What would you guys like to see more of? Avery. Okay, that's fine. I'm just saying if there's any specific type of problems we want to see, go ahead, let me know, and we'll work through some examples. If not, Zach? Never mind. Alright, so what if we had a problem that looked like the square root of 7 over the square root of 6? Starting off with one that we should be very familiar with. We can't simplify the original radicals, so all we need to do is rationalize. To rationalize the denominator, what do we need to do? Multiply by the square root of 6 in the numerator and the denominator. So square root of 7 times square root of 6 equals square root of 42. And square root of 6 times square root of 6 equals square root of 36, which does equal 6. So we have square root of 42 over 6. Can we do anything else to that problem? Are we all thumbs up comfortable with rationalize the denominator in that fashion? Give me thumbs up if we're good with those types. Are there any thumbs down with those types? We're all good? Okay, so let's have some problems that we can simplify first with. So let's say we had 15 square root of 10 over 5 square root of 3. How can we start by simplifying this expression? Jacob? Good. So we can simplify this 15 over 5 to 3 square root of 10 over 1 square root of 3. Do we all see how that worked? So now we need to rationalize because we've simplified. To rationalize, we're going to multiply by the square root of 3 to the numerator and the denominator. From here, we need to multiply our coefficients and multiply our radicands. Zach? So we got 3 square root of 30, and 1 times 1 is just 1. Square root of 3 times square root of 3 is the square root of 9. Now we need to simplify this expression. So we have 3 square root of 30 over the square root of 9. What can we still do? Simplify the denominator. So the denominator can be 3, because the square root of 9 is 3. And we have 3 square root of 30 over 3. Are we done? We can still cross out those 3's. And our final answer is the square root of 30. So there's a type of elimination problem with the coefficients. Zach? Problem is at what? Perfect squares? There could be some in the numerator, yeah. But if it was some in the numerator, we simplify first. Say it was the square root of 81. If there are in the denominator, we're working. We're in a perfect square. Right now we're working with rationalizing the denominator, so a lot of them are not going to be perfect. Most all of them will not be perfect squares with rationalizing the denominators. There could be one, but if that was that, you just simplify and simplify from there, right? So let's say we had another one. Say we had the square root of 216t over the square root of 6. No. So 6 goes into 216 36 times. So we can simplify our radicals. So 216 divided by 6 is 36, as Noah said, and we can't forget about that t. And then 6 divided by 6 is the square root of 1, and the denominator will just be 1 in this case. Now we need to work on simplifying this. Square root of 36 is 6. What's left in the radical? Square root of t, and that's over 1, because the square root of 1 is just 1. So there's a simplifying inside the radical problem. Would we like to see more of a certain kind? More like that one. Zach? More like simplifying inside the radicals? Okay. Let's say we had 48, the square root of 48 x cubed over the square root of 3. What do we need to do here? Yeah, it's a 3 in the denominator. So Square root of 48x cubed over the square root of 3. 48 divided by 3 does give us 16. So we have the square root of 16x cubed over the square root of 1, which will just be 1. So from here we need to simplify. Simplify the square root of 16x cubed. How do we do that? Four x square root of x. And how'd you get there, Noah? Good. So anytime you have an odd exponent and we're taking the square root of it, take 1 out, make it an even, divide by 2. So if we take 1 out, that gives us x and x squared. X squared gives us x and x, and there we have our pair, which we pulled out, and 1 we have left. So our answer is 4x square root of x. Other types of problems we'd like to see. Okay, let's say if you saw a problem that looked like square root of 3 times the square root of 2 over the square root of 7. Derek? So we multiply in our radicands. We have a 3 and a 2, so what do we have? So we have the square root of 6 over the square root of 7. Nothing can be simplified, so now we need to rationalize. If we rationalize this, we have the square root of 7 over the square root of 7, because the square root of 7 is what is in the denominator. And square root of 6 times the square root of 7 gave us square root of 42, and square root of 7 times square root of 7 gives us 7, or the square root of 49, which is 7. Any other examples we'd like to see? Or do we feel comfortable to start the homework and ask questions as it goes along? Thumbs up? We're good? Taco Bell good to go? Alright, so your homework is posted on Google Classroom. It is 2 sections of 9 problems.